Welcome to the Waze talk at PyData. We're going to be telling you a little about the evolution of Python data and research at Waze over the years. And let's start by introducing ourselves, I think. So my name is Sagi, and this is Tzipi.
I'm Tzipi. Hi.
And we've been working together for the past 5 years or so, I think. So I actually started working in Waze about 8 or 9 years ago, something like that. And about 5 years ago, I interviewed Tzipi, and we've been working together ever since.
Lucky me.
So we've exchanged a few teams over the years. We survived a few reorgs, I think, and we've worked on a range of stuff from data infrastructure to parking features and all kinds of stuff. And today we're both part of the routing and ETA team, part of the Waze backend development. So that's us. So we'll be telling you walking you through the evolution of data and research at Waze through the years. Sort of just to give away the ending, this is it ends with our love story with Jupyter, or more accurately with the combination of Jupyter and PySpark and Pandas and Plotly and all of these packages bundled up together. So that is sort of the ending. Now let's see how we got there. So yeah, so this is sort of the agenda. We'll talk about MapReduce and Spark and some turning points along the way and schemas or schemaless and yeah, all sorts of stuff. We'll just go through that. Okay, so I want to start back in 2009 when I started working for Waze, and so back then this is sort of the way I was doing research when I started. So we were using a tool called QGIS, which probably most of you have never even heard about. And this is the tool I was using. It's a pretty nice tool that sort of allows you to do geographical visualizations of data. Sort of like put map layers on top of GPS points and all kinds of geometries and just visualize them one on top of the other. So it's a pretty nice tool, and by pretty nice, I mean this was a god-awful, horrible way to work. It was really awful. Not so much maybe because the tool was awful. The tool was, well, you could have improved it. It was nice. But really the way we were working was really, really not interactive. And we'll see that evolve over the years. But basically we wrote our Java code, and the Java code outputted whatever we wanted to visualize. Then you had to create a jar. You had to upload it to some server that had access to all the other servers and databases and everything. Then that server outputted what you wanted to visualize into a file or into a Postgres database, and then you had to configure it all in QGIS to have it load everything, and only then you saw your data visualized. And it was such a long feedback loop that it was really cumbersome and hard to do, and took like from hours to minutes to days sometimes. So this was an awful way to work, but we got stuff done. I mean, we did research with it, and we got stuff done, so it kind of worked. And whenever we needed to plot stuff, I guess we just used like spreadsheets or whatever common software we had available. So if you move forward like a year or two, this is when structured data started to appear in Waze, sort of. So before this, basically all the data was just unstructured log prints. Like servers were just printing stuff into logs, just whatever they wanted to print, exceptions and I don't know, descriptions and stuff, just free text. And people would look at that. And around this time is when structured data started to appear, and was mostly CSV at the time. So servers started to output their data in structured CSV with fields and everything. But the data never came with a schema. So like if you wanted to actually process the data or figure out what was going on, you have to look at the code of the server or try to figure it out yourself and sort of figure out, okay, column 5 is like the date and column 6 is that field and whatever. So you had to do all this work manually. Okay, looking another year or two forward, this is sort of when we started to use, so the volume of data in Waze was starting to really grow and grow massively and started to outscale us. And so this is around the time that we started using actual big data in Waze. And this started out as using MapReduce in Java to actually process the data. So we started moving processes to use MapReduce in Java. Stuff like taking all the speed measurements and averaging them and having like a speed average for every road segment and different hours of the day and different days of the week. These sort of mass processing that we had to get done to get ETA, for example, and stuff like that. We started moving that into MapReduce. And around the same time, the analytics department started working with Hive. I don't know if you guys know Hive. Hive is sort of like this SQL language that basically operates MapReduce behind the scenes. They started using Hive, which basically meant they were running MapReduce over all of the structured data that I mentioned before. As I said, none of this stuff came with a schema, so the analytics department basically started manually maintaining their own schemas of everything in order to be able to run queries on it and research. So again, things started to grow massively, and as things started to grow massively, even simple things like grepping logs for exceptions or trying to debug something started being really outscale or non-practical to do. I mean, developers used to just, download their log and grep it to figure out what was going on. This started becoming really non-practical as we got into massive growth. So to solve that, this is around this time we also developed what we internally call the EMR grep software. It's not much of a software really, but it's basically sort of the script, and this is really how it looked like or still looks like. It's a script that's called the EMR grep that sort of lets you say, okay, you say EMR grep, you say the path of where your logs are in S3. You can use a star like to get all the logs from all of your different servers. And then you just put the string and you sort of grep it as if it was just a normal grep command. But really what happens is the script SSHs to this cluster that's always up and running. This cluster has a cluster in AWS, and this cluster always has Hadoop MapReduce and everything installed on it. And it just runs MapReduce on all of your logs, greps it, sort of a grep reduce kind of program, and just gives you back the lines and the logs that match whatever you're grepping. So all developers basically started to use MapReduce, even if they weren't really aware of it most of the time. And actually, I think it's still predominantly used to this day, right? I mean, yeah. So it's starting to get less and less as people get to know Jupyter and stuff we'll get to later. But I think it's still mostly used by developers whenever they want to just get something from their logs or their unstructured data, just to get that line back. Okay, more evolutions that happened. That's Dragonite. More evolutions that happened. So with visualization, if you remember QGIS I talked about before, so I guess it was around 2013. I don't know. We kind of randomly guessed some of the dates here, but it's hard to date back. But I think it was around 2013 that we sort of got sick of using QGIS. So we moved to trying to visualize stuff over our Waze map editor. Waze map editor is it's a website anyone can access in the Waze.com. Okay, it just lets you edit the map or have suggestions for edits. So we had this sort of internal version of the same website that we just had JavaScript on top of that let us visualize data and play with it on top of it. This was a big step forward in terms of researching data and playing with it, because you could do stuff that you could never do in QGIS. You can click on a segment and then display just the data that's relevant to that segment, like roads, just data relevant to that road. Then you could click on another road, that data disappears, new data just relevant to that road appears. You can there was interaction going on, stuff that were never going on when we were working with QGIS. With that said, it was still, very, a lot of stuff were difficult to use because you still had to write like a MapReduce code to get all of your data, to bring all of your data, process it into something that this layer could read, and upload it to S3. And only then you could use this JavaScript layer to actually play with the data and look at it. So this was a step forward in visualization. We move another E forward, I think. So more data formats started to appear in Waze, more structured data, mainly stuff like protobuf started to appear. So servers were starting to use protobuf as their structured data instead of CSVs. And if you thought CSVs were sort of hard to query with, MapReduce or Hive or whatever you're doing, protos are pretty much impossible. You can start trying to write plugins for it and stuff to make it work with Hive, but it's really difficult and it's hard to get to work. We tried doing that for a while. And also we started using Cassandra databases, not just Postgres, which are sort of non-SQL databases, and probably some of you are familiar with those. Cassandra databases are also, difficult to work with in the sense that they're great for online servers, but if you want to start querying that data and joining it with other data from structured data that your servers are outputting, it's pretty hard. It's not really easy to do. But basically, what we managed to do eventually, and we is not us specifically, but other people, is just have this process written with MapReduce that takes all the files from the Cassandra nodes themselves, from the database nodes. It's basically SS tables files, if you guys are familiar with it, and just run a MapReduce process on that and output everything in a CSV or some structured format that you can now run, your querying on it. So this is the process that was developed sometime later after we started using Cassandra. And this is still used to this day, I think, basically. So the CSVs are now Parquet. We'll talk about that later. And the MapReduce is now Spark, but this process is still up and running. This is the way we used to query Cassandra data offline and join it with the rest of our data. Right, so we're moving another year or two forward. We started moving from MapReduce to Spark. So I think in 2015, 16, probably Spark was already there for a while. I don't think we were that early adopters at all. But this is around the time that we got around to using it. And we just started writing new things in Spark instead of MapReduce and slowly converting all MapReduce stuff to Spark. I think today, like probably 90% of our pipelines are now Spark, and just a few legacy ones are still in MapReduce. Okay, so now we reach sort of a turning point in our story. And this is where the Waze Beacons project sort of joins up with our story. Waze Beacons, I think, started actually in 2016, kind of, and not 2017, but it joins our story in 2017. So just to explain what the Waze Beacons is, if maybe some of you are familiar, we were basically trying to solve this problem of navigating in a tunnel or someplace where you don't have any GPS reception. So, and the main thing to accomplish was to be able to give you instructions when you reach a turning point in the tunnel, right? Turn right or turn left in this intersection. Even though this intersection is has no GPS reception, it's underground, we still want to be able to give you that instruction on time so that you make the right turn. This was a big problem before we had this solution. And this is what the project was trying to solve. And the way it solved it is basically we install these Waze beacons. That's like a real live one. I think that you took that picture from my desk. Where'd you take it from?
I stole it from someone else's.
Oh, it's not mine?
Maybe it's your hand. It could be your hand.
No, not, but my beacon.
Ah, maybe.
Okay. I think she stole my beacon. Okay. So that's a real bit. That's what it looks like. You basically take that and just tape it on top of the tunnel every so-and-so meters. And it's just it's sort of a Bluetooth transmitter. And then your phone or the app picks up the Bluetooth signals from these transmitters and just pinpoints your location using that Bluetooth data. That's the Beacons project. And where this joins our story is that what we were trying to accomplish is just to have this sort of algorithm that would pinpoint that we would let like vendors install all of these beacons by themselves, not having to start to coordinate stuff with us, and then trying to develop an algorithm that on our side would just pick up all the Bluetooth signals for people passing through these beacons and try to figure out ourselves like which beacon ID is installed where in the tunnel and in what order, okay? This is sort of the project we were trying to accomplish and where all this joins our story. So you want to continue?
Okay. So, and here comes one of our favorite team members. All of our team members are favorites, but His name is Daniel. Today he's working in Zurich in Google, but like a few months ago he moved. But he moved to our team from the web development team, and he came with all the front end knowledge and all the being organized and doing stuff fit like really well. So when he got this project, he was like, how am I supposed to do, like, you expect me to write some Java code, put it somewhere, then somehow get the output and put it on top of the Waze map, and every time I want to fix like some bug, I have to do this all over again. It's like this, it's like he wanted like a really short feedback loop for testing his ideas. So lucky for us, he's really inventive and very knowledgeable in everything related to front end. So we researched what is going on, what is popular right now, and he came up with he found that Jupyter Notebook could be a really good solution for the research purposes, and he basically managed to set up a notebook on his laptop with all the necessary access to all the databases, etc., S3 locations, and everything he needed for his research. And he basically managed to write PySpark code, which is Spark written in Python, and use the output to display geographic information on top of Folium map, which is, if you know Folium, it's a Python library that envelopes, I think, Leaflet. It's a JavaScript other library, and basically it displays the geographic information on top of OpenStreetMap. So, and also, of course, he used Plotly for graphs. So we were like, wow, mind blown. Man, how did you do this? This is amazing. We didn't use it before. Like maybe some of us, sometimes use it for doing something really, really simple, but we didn't know it was possible to do all these amazing things with this open source tool. So, of course, everyone were super envious. And because you can see what he managed, you compare that with the stuff we did before. I want to share a personal note that when I joined Waze, one of my first tasks was getting that JavaScript code used as a Chrome extension, which was for me like a big step in frontend, because that was the first thing I did in frontend, and was like, oh wow, I was so proud of myself that I managed to do it. And then he comes up with this. This is insane. So we all of us really wanted to work with it as well. And Sagi suggested that Daniel will find a solution for it to be a central point of access that everyone can use, like everyone in our team at first, and so everyone could use it for researching it. And really, like, it took like, I think maybe 2 months or something like that for it to be up and running, and for almost all of our team using it, which was really, really super cool. I didn't mention that he used Jupyterhub, which is it's a sister project of Jupyter, which basically used for setting up a main server for like academic research. Like if people want to have, like, that's how they publicize it on the website. Like I don't think they specifically mentioned what we are doing with it, but maybe they did. So so that was really lucky for us that it became so popular at the same time. So and now the plot thickens. And Sagi will let you know.
Right. So we'll actually show a live demonstration of the Jupyter in just a few slides. But just to sort of complete the picture that we're going through time here. So this is really a project that we did this year. This is really fresh stuff. We've reached 2018 pretty much. And this is a project we call the Grade Wall of Schema. And its purpose was sort of to close things around. If you remember, I said everything up to now, the structured data, did not have a schema with it. People kept maintaining everything manually. And the main purpose of this project was just to get all the structured data coming out with a schema automatically built into it. And on the way, we also solved all these problems with protobufs and all these other structured data that were not easily queryable. And the solution was basically to transfer everything into Parquet. So the servers were still running as normal and using protobuf, CSVs, whatever they're using before, but we had jobs in place that could transfer everything into Parquet right as they were outputted. And then Parquet is easily queryable by Spark, definitely easily usable in PySpark and Jupyter or whatever you want. And it has a schema built into it, into the files. So this was the great wall of schema, right? Purpose was to get all these schemas automatically with everything and all the data in a queryable format. Okay, right. So just at the end of that project to close everything up is when we added the Waze data library inside Jupyter, which is what we'll show you in a second. And basically the purpose of this library was, now that all this data is available in Parquet with a schema, with everything, just to make it all super easy to use with completions, everything inside Jupyter. And the way it goes, you'll see in a minute, you hit waze.data. And then you get a list of like tab, you get a list of servers. You can hit dot again, like on a server, you get tab, you get the list of all the structured types of data. You have that server, dot load for some date, and then you can start working with the data immediately. So that was sort of the Waze.data package that we now all use. Okay, so now it's a live demonstration.
Yeah, let's do it again. Yeah.
Yeah. So today, basically, everyone in Waze or anyone with the proper permissions can just hit go/Waze Jupyter, and they get immediate access to the Waze Jupyter notebooks. And we've prepared one in advance, I guess, just to show you what it's like. So this is like an actual notebook, okay? So just to demonstrate this, okay? So say I want to now access our map, okay? So I do Waze.data. You get all kinds of data here, okay? So I know the map is saved in a Postgres database, so it's Postgres. You can have, you have Cassandra here, or or you have events is like structured, just log data, and you can access any of those. So we hit Postgres. Now we have all the types of servers that have Postgres. We have 2 databases still using Postgres, that's live and users. So live is basically the server that holds the map itself, yes. And then there's only segments here. Segments is basically
like all the parts of the
your keyboard is not set up for me. Okay.
Yeah, it's not.
Dot segments, and everything has completions. And now let's just run this. Okay.
Yeah. Now we're loading.
Yes, the latest snapshot of the map in Israel, I guess, right?
Yeah.
Okay.
It would take like 1 minute or so.
Okay, and afterwards, what we're going to do is just query all the segments that have over 3 kilometers. Yeah. 3,000 meters, and take the first 500 of those. We'll just run that. And after that, we also have the Waze.map library where we can visualize stuff over the Waze map. So we create a map of, connecting to the Israeli map. And then...
And we add the layer of all those segments that we just queried.
Yes, this is this Python code. So let's do that.
Want to ask? Oh, you want to wait one bit? We're getting to the end. You can ask all the questions you want. It's okay. Is that okay?
Okay.
Enlarge the fonts. No problem. Sorry. Oops, too much. Okay. Better.